Hello everyone. So today we are going to discuss machine learning. So the first learning outcome statement is describe supervised machine learning, unsupervised machine learning and deep learning. First of all, let's see what's the difference between statistical approaches and machine learning. In the statistical approaches, they rely on certain assumptions, like the assumptions regarding the distribution of the data, and then you define the characteristics of that data to analyze it, right? But in machine learning, you kind of extract knowledge from large amount of data. You have got a very large amount of data, and you do not know the exact distribution of the data, and you try to extract knowledge out of it. Machine learning is called as find the pattern and apply the pattern. Like, first of all, you kind of find the pattern from the data that you have, and then you apply that pattern to the incoming data to make certain decisions. So the machine learning can be divided into three types of machine learning. First is supervised machine learning. In supervised learning, you infer patterns between a set of inputs and the desired output. In this particular type of learning, you got a kind of labeled data, like you know that these are the inputs and these are the outputs. Each input is mapped to a certain output, so that is a labeled data. What you do is, during the training of the model, you try to infer the pattern that is defining the data. The dependent variable is known as the target variable, and the independent variables are known as the features. So you try to infer a particular pattern to decide, like, these features belong to this particular type of target variable. So there are two kinds of problems in supervised learning. First is a regression, second is classification. Regression problem means that your target variable is continuous variable, like you are trying to predict some value, okay? And in the classification, your target variable is categorical target variable, like you are trying to classify that particular type of data, like this data belongs to this category, this data belongs to this category. So these are two types of problems in supervised machine learning. Then comes the unsupervised machine learning. The unsupervised learning does not use any kind of labeled data, as the algorithm seeks to discover relationships between the data itself, and it is useful for exploring new datasets, the datasets for which you do not have any kind of knowledge, like you do not know that this data belongs to this category, this data belongs to this category. So in this type of data, the problem is like there are two kinds of problem. First is dimension reduction, second is clustering. The dimension reduction means that you try to reduce the number of features that are required to describe the data itself. You reduce the number of features, and while preserving the information about the data itself. And the second problem is clustering. Clustering means that you kind of group the data into some particular cluster, and each cluster has similar observations, and these observations are different from observations in other clusters. Like you are trying to grouping the data here in clustering. Then comes the deep learning part. Deep learning is based on neural networks. It is used to perform highly complex tasks such as image classification, facial recognition, speech recognition, etc. There comes a reinforcement learning, which is also a part of deep learning. Reinforcement learning is when a computer learns from interacting with its environment or the data generated by the computer itself. Now, to analyze the fit of the particular model, you need to know what an underfit or an overfit model looks like, and what is a good fit. So the underfit model, in an underfit model, see, suppose you have got this data for these particular circles and triangles, and you are trying to find a model which categorizes these circles and triangles into their groups, right? So an underfit model looks like this. It is not properly it is not properly dividing your data in these particular groups. Like it's just a random line. It's an underfit model because the predictions made using this model will be incorrect. and overfit model looks like this curve. So this model is overfit because it has kind of adapted itself so much to the training data itself. Like for example, if in the testing phase I give it a triangle here, it will not be able to adapt to it. It will it will categorize this triangle into a circle itself, because the data is overfit on the training data itself and it is a particular curve here, right? And a good fit model looks like something like this. It may make one or two mistakes, but if but in the validation phase, your error will be much less than this model. So in terms of the error, you can see these underfit and overfit model like this. When a model is underfit, it has a high bias error. When a model is underfit, this is underfit model, this is overfit model. So when a model is underfit, it will have a high bias error, like the model is not performing good on your training data itself. That is called bias error. And as you increase the complexity of the model, the bias error starts reducing, keeps on reducing, and your variance error keeps on increasing. The variance error is the error on the validation data itself. So you have to make a trade-off between the bias error and the variance error, and you have to reach this particular optimal complexity point. And you have to reach up to this optimal complexity point so that your model is performing good on both the training data and the validation data. Now, how you can avoid the overfitting of model? To avoid the overfit, you have to estimate a penalty term. The penalty is like the penalty term is when you include a particular feature to your training data, the penalty will increase, and you will only add that particular feature. It is if it is providing more information to you than the penalty that it is bringing to the error term. And a cross validation is you have to do the data sampling. You have to define the data into particular data sets, and you kind of, first of all, let's look at k-fold cross validation. In k-fold cross validation, you divide the data into k subsets, then you take the k-1 subsets as the training data and the kth set as a validation data, and you repeat this step k times, each time taking a different set as the validation data and different k-1 sets to train the data. And the average of those k errors, you have repeated the process k times, right? So the average of those k errors is taken as a reasonable estimate of out of sample error. That is k-fold cross validation. Now we will discuss the different types of supervised machine learning models. The first model is penalized regression. In penalized regression, we include a constraint that the regression coefficients must be chosen to minimize the sum of squared residuals plus a penalty term which increases in size with the number of included features. So when you include a particular feature, you increase that penalty term. That penalty term is added to the sum of squared residual. So your overall objective is to reduce the sum of squared residual. But when you add a particular feature, you are adding a penalty term to this squared residual number. So you will only add that feature if the overall sum of squared residual is decreasing after adding the penalty term. So included feature must make a sufficient contribution to the model fit to offset the penalty from including it. Okay, so the example is like a lasso model, least absolute shrinkage and selection operator. Here the penalty term is defined as lambda times this term. Here lambda is the hyperparameter. A feature is included only if the sum of squared residual declines by more than the penalty added. The second type of model is support vector machine. In support vector machine, it is a linear classifier that determines the hyperplane that separates the observations into two sets of data points. So it is like this. This line here, this is called as support vector, and this difference, this is called the margin of, it is the margin of this vector, and there is a trade-off between a wider margin and a lower total error penalty. The wider the margin, the more will be the penalty. The third type of model is k nearest neighbors. In k nearest neighbors, it is used for classification. The idea is to classify a new observation by finding similarities between the new observation and the existing data. So here k is a hyperparameter. You define k so that you are, by defining k, you are telling the machine learning model to how many neighboring observations that model check to come at a conclusion. For example, in this you have defined k is equal to 1. So this is the new observation, the red triangle, and you are trying to classify it as a triangle or circle. This is your new data. So if k is equal to 1, what the model will do is it will look for the nearest one neighbor. The nearest neighbor to this new data is this triangle. So what it will do is it will look in the nearest neighbor to it and categorize the new data based on the neighbor itself. Since it only has one neighbor, that is a triangle, and it is nearest to it, it will categorize this triangle as a triangle. Now suppose k is equal to 5. Now what it will do is it will look for 5 nearest neighbors, and it will create like these are the 5 nearest neighbors to this new data set, and it will take the majority rule here. So the majority number of these 5 is triangle. So it will categorize this data set also as a triangle. The decision rule is to choose the classification with the largest number of nearest neighbors out of the k neighbors being considered. Now the different values of k may lead to different answers. Okay, suppose here instead of k is equal to 5, there was k is equal to 7. So we will take the nearest 7 neighbors like this. And if I take these 7 neighbors, 4 out of these 7 are circles. So it will categorize the new data set as a circle. So the different values of k may lead to different answers. So the next model is classification and regression tree. It is a pictorial model. You can visualize the things here, and these are the you can say these are the decision nodes. These are the end nodes, right? So at every decision node, that model, what the model will do is, model will first of all, during the training, it will create some features and cutoff values of those features. These cutoff values are used to divide the data into particular segments. So when you provide a new data, you provide a new observation to the model, it will check the data for particular features and their cutoff values on these decision nodes. And different branches will be used depending upon the data. So the same feature, it's not necessary for one particular feature to occur only at one decision node. The same feature can appear several times on different decision nodes, and the regularization is achieved through pruning. Pruning is, once you train your model, there might be a number of different branches out of the tree coming out on the tree, and you see, like, you analyze that which branches are providing minimum information to your decision. So you can cut off those branches out of the tree. That process is called as pruning, cutting off branches which provide minimum information. That is called pruning. The next topic is ensemble learning. Ensemble learning is combining the predictions from a collection of models. Okay, there are two categories of ensemble learning. First is collection of heterogeneous learners. In this type of learning, you train different types of models on the same data. That is why it is called as heterogeneous learners. And then you you decide the data to be used as a voting classifier, like depending upon the majority of votes, you can say. So suppose you train 3 different types of models on the same data, and 2 models are saying that this is a winning fund, and 1 model is saying this is not a winning fund. In that case, you will select the you will make the decision depending upon the majority vote. And that since 2 models are saying that it is a winning fund, you will say that it is a winning fund. And the second category of ensemble learning is homogeneous learners. In homogeneous learning, what you do is you use the same model, but you train it on different data sets. And how you come at these different data sets, that process is called as bootstrap aggregating, bagging. What you do is you take data, like suppose you have got a particular data set. What you do is you can take different sets of data from the same data set and then train that particular data using these different data sets. That is a bootstrap aggregating. Now let's discuss random forest. Random forest is a collection of large number of decision trees trained via the bagging method. The bagging method that we explained here. For any new observation, we let all the classified trees undertake the classification by majority vote. It reduces variance and protects against overfitting. The drawback is that it lacks interpretability of individual trees. It is called as a black box type of algorithm. So what you do is in random forest is you take a large number of decision trees and you train them using the bagging method. And the basic motive behind random forest is it reduces your variance error, that is the area error that you get on the validation set or the actual data set. And it also protects against overfitting. See, if the actual data looks like this, if you use a linear model here, the linear model will divide the data in like this only. But if you use the random forest will actually give you answers comparable to the actual data. Now let's discuss the unsupervised machine learning algorithms. So there are 2 types of problems in the unsupervised machine learning. First is dimensionality reduction and the second one is clustering. In the dimensionality reduction problem, what we do is we transform highly correlated features of data into a few main uncorrelated composite variables. So by composite variables, what I mean is you take 2 or 3 multiple features and club them together and make it as a one feature. So this feature contains all the data that was represented by these 3 features. So a composite variable is a variable that combines 2 or more variables that are statistically strongly related to each other. So these features must be strongly related to each other. So we combine those features and represent them as a single feature called composite variable. Now there is a trade-off between a lower dimensional, more manageable view and the loss of information. So suppose the original data contains 20 features, right? And while reducing the dimensionality, what you do is you represent these 20 features with 5 features. So the data with 5 features is more manageable than the data with 20 features. But there might be some loss of information when you reduce the dimensions. So the scree plots are the plots that show the proportion of total variance in the data explained by each principal component. So for example, your original data has 6 features. So what you do is you represent this is the variance the percentage of proportion of variance represented by each feature. So the first feature itself, the first feature explains about 40% of variance. The second feature explains about 30%. The third feature explains about 20%, and so on. So the top four features, these four features represent approximately 95% of the total variance. So you can discard these two features and represent the data using only these four features, and you will be describing the 95% of the total variance in the original data set. So the data will be represented using lesser number of features. As you reduce the dimensions, the data becomes more manageable. The drawback of PCA is, since principal components are combinations of features, they cannot be directly interpreted by the analyst. There might be some loss of the interpretation when you combine two or more multiple variables into one feature. So that's why PCA seems to be like a black box algorithm, because suppose upon reducing the dimensions, you are left with four features, but these four features are not directly interpretable by the analyst. They are not related to any kind of economic variables or financial variables. So that's why it is called as a black box algorithm. Now the second problem in the unsupervised machine learning is the problem of clustering. Clustering is used to organize data points into similar groups called clusters. A cluster contains a subset of observations from the dataset such that all the observations within the same cluster are deemed similar, and observations in two different clusters are as dissimilar from one another as possible. So what you do is, suppose your dataset contains triangles and circles. So while creating clusters, you create clusters such that the data in one cluster, observations in one cluster, are as similar as possible. So you divide this data into two clusters, one cluster is containing triangles and the other cluster containing circles. So the data in one cluster is as similar as possible to each other, but they are different from the data in other clusters. There are two types of clustering algorithms that we can use. The first algorithm is k-means clustering. In k-means clustering, you divide the data set into k clusters. The k here is a hyperparameter and it must be defined before running the algorithm. So each cluster is characterized by its center called centroid, and each observation is assigned to cluster with the centroid to which that observation is closest. Suppose you define k equals to 3 and run a k-means clustering on this data. So what the algorithm will do is, it will divide this data into three clusters. It will first of all look for three centroids. Let's see, the first centroid is this, the second centroid is this, and the third centroid is this. So it has divided the data into these. To divide the data into three clusters, it will look at the observations, and the observations that are closest to this centroid will be combined together. Let's say this will become your one cluster, this will become your other cluster, and this will become your other cluster. So upon dividing the data into clusters, what it will do is, it will recalculate the center point of each cluster. So let's say we got these four observations in this cluster. It will recalculate the center by taking the average of all observations. Now let's say the average of these observations is this point, and average of this cluster is this point, and the average of this cluster is this point. So now in the next step, what it will do is it will recalculate the centroids. So upon recalculating the centroid points, it will reiterate through the process and combine the data into other clusters. So this process keeps going on until the algorithm has minimized intra-cluster distance, that means the distance in the observations belonging to the same cluster, and maximized inter-cluster distance, the distance between one cluster and the other cluster. So the next algorithm is hierarchical clustering. In hierarchical clustering, there are two types of procedures used. First is agglomerative, second is divisive. Let's discuss agglomerative clustering. So in this process, first of all, each observation is defined as its own cluster. So each observation is its own cluster. In the then you keep on combining the clusters together. Let's say these two items are combined. Then you combine two of such clusters. Let's say you combine this cluster with this one, and you combine these three clusters together. Then at the last step, all these observations will be clustered into one cluster. And for the divisive process, it is the opposite of agglomerative. First of all, you create a cluster which contains all the observations, and then you keep on dividing the cluster into smaller parts. So let's say now you divide the cluster to be in these two clusters. In the next step, they will be divided into other clusters, smaller clusters. So the main difference between hierarchical clustering and k-means clustering is, in the k-means clustering, there is no relationship between different clusters. So let's say this is cluster 1, this is cluster 2. There is no relationship between cluster 1 and cluster 2. Whereas in hierarchical clustering, you can say there is a certain type of relationship between each cluster. Let's say this is cluster 1, this is 2, and this is the larger cluster 3. So the cluster 1 and cluster 2 are a part of cluster 3, whereas cluster 3 is a part of cluster, you can say this bigger cluster is cluster 4. So the cluster 3 is itself a part of cluster 4. So there is a hierarchical type of structure here. The next topic is describe neural networks, deep learning nets, and reinforcement learning. So a neural network has three type of layers. The first layer is the input layer, the second is the hidden layer, and the third is the output layer. The input layer is where we provide the input to the network. The main processing of the algorithm occurs at this hidden layer. There could be a number of hidden layers depending upon the algorithm. So each node in the hidden layer has two functions. First is summation function, second is activation function. So the summation operator multiplies each input to its respective weight and sums the weighted weights to form the total input. So the first function here is the summation, where you find the total input to the algorithm, or you can say total input to a particular node. The second function of the node is activation function. This activation function transforms the input into the final output of the node. It operates like a light dimmer switch that decreases or increases the strength of input. So once you find the total input, after that the activation function works as to reduce the input, like whether you want to increase or decrease the strength of the input. That is done by the activation function. Activation function works like a sigmoidal function. The neural networks lack interpretability and are known as black box algorithm because you do not know what is going on in this hidden layer of the neural network. That's why they are known to be black box. The deep neural networks are those which have at least 2 but generally more than 20 hidden layers. When the number of hidden layers increases, it is called as deep learning neural networks. Deep neural networks. The last type of learning algorithm is called as reinforcement learning. It has neither direct label data for each observation nor instantaneous feedback. The algorithm observes its environment and learns by testing new functions. The algorithm keeps on learning through trial and error.